Okay, this Hangout on Air is live. Welcome. We have Roberto Cortez and myself in the same room for once.
Exactly.
How are you doing? How did you get into my room?
Well, I'm here in the UK for the eBooks in the next couple of days, and Simon's always here, so
yeah, always around.
yeah.
So yeah, we're actually here from we're actually in Hilton.
Yeah, we have like a nice London map.
So yeah, this today's VJug session is brought to you via Zero Turnaround and DoubleTree by Hilton. So we've got a double sponsors today. If something does go wrong with the Wi-Fi, it's Hilton's fault, not Zero Turnaround's, obviously. Okay, so unfortunately, Josh looks like he can't be with us right now, but we are pinging him to see if he can join. But this basically means that we're going to be expecting people from the youth group to join us. So if you do want to join us, I'd like to see Mr. Eder. I see you there. Perhaps join us. I'd love to see Harmeet on. PM771 would be great if you could join. So we can. Here's Josh. Awesome.
Hi, better late than never.
How are you doing, Josh? We are live on the virtual jug. You join us just as we're starting. So we're also saying that it would be great if others could join and have a discussion to say hey. It's a shame you can't be with us here in Devox London.
Yes, it's too bad because if I were there, I could go to one of your fine pubs and some of your fine ale. On the other hand, I suppose, cheers.
Cheers.
You say that just as we're sipping on some beers. Sadly, they're not some of Britain's finest ales.
Lucas seems he wants to join. Let's send him the link to join the hangout.
Let me send Lucas.
Send anyone, and I'm going to get up, but it's just to grab a copy of my book from this bookshelf. So if anyone asks me anything specific, I can say, "Oh well, on page 37 it says whatever, right?" All right.
I've just sent you a link, so feel free to join. So Lucas is actually one of our speakers on the virtual jug before. He gave a session on Duke, which is a framework or more of a library, I guess, to be able to generate build SQL or deep down into SQL queries in an effective way.
And I enjoy hearing Lucas. He's a very awesome guy.
Yeah, he's great. We'll speak to him very soon.
And it's named after this fellow. I'm not sure if you can see him, but I'm wearing my Duke Constellation shirt today.
Awesome.
Yeah.
Awesome. Okay, so in this session, we're going to be talking about pages 100 to 200 of the book.
Yeah, basically that picks up the enums and interfaces plus the what we have next. Generics as well.
Mm-hmm. Yep.
And methods. So roughly those pages are picking up those topics.
Mm-hmm.
We're having Mr. Lucas with us now.
Lucas, you didn't even have time to shave. Hi
there.
How are you?
Lucas, can you hear us? Okay.
So, let's get started then. If anyone has any questions, let me go to the virtual jug page. What we'll do is we'll start with some of the questions that we had left over from the last session, and as and when people have some questions for the new sessions, we can, as you say, talk about generics. I guess is going to be one of the hot topics that was written about in the book. That was obviously one of the big additions into Java 5. So
let's also do like a small recap here from the last session, I think.
Sure.
For the guys that haven't joined for the first session, you can always have a look into the videos on the Big Jug that are available on the web. And I also want to mention that Josh is planning to write another book based on Java 8 stuff. I'm guessing that some of you are going to ask about those questions because probably a couple of things that we're going to discuss here, or there were in the book on the generics, enums, interface, and methods sections, are a bit outdated, or at least a few of them are a bit outdated for Java 8. So don't worry about that. Just going to write a new book but for the moment, let's just discuss what we have here.
Some are even outdated for Java 7.
Yeah, exactly.
So if you have any Java 7 or 8 questions, feel free to ask. If they're Java 8 questions, I may not be able to give you good answers. I cannot, I can tell you the puzzlers in streams yet because I haven't used them enough to find the puzzlers.
Okay, awesome. So let's grab a question for you, Josh.
All right.
That question. Okay, so this is one from PM771, who's also here today. Question is, for each, the compound for each is referred to as syntactic sugar. Is it really just that? Is it that, or is there anything under the covers which is really?
That's all there is to it, and I think it's a powerful example that it may just be syntactic sugar, but it sure is sweet. It's, I think, perhaps the best feature that was added to Java 6. Let me get that right. Java 5. I have one big regret concerning it, which is that I did not add support for strings. One should be able to, not just for strings, but more generally for char sequences. It should be possible to enumerate over the chars in a string, most importantly, and then while you're at it, string buffer and the like. It's still quite verbose to iterate over the chars in a string, and this would have been the perfect opportunity to take care of that as well. But I think that it makes Java programming so much more fun. I think thinking about Java without for each would be a nightmare. And if I may editorialize a bit, I think it's a damn shame that other features of that ilk, well, first of all, that one hasn't been sort of finished in the intervening, whatever it is, decade, and that other features of that ilk have not been added in the intervening years. I think that a lot of the stuff that in Java set was done in I got to get the numbers right here. A lot of the stuff that was done in Java 8, is good, but I think collections literals would have been a much better use of their time than, at least some of the more arcane features of streams and so forth, in terms of actually reducing the verbosity of programs and making the language more fun. If you look at new languages, yeah, they all have lambdas, they don't all have streams, but they do all have some really quick, easy, effective way to express a literal list of numbers or a literal map from strings to numbers or what have you. So I think it's a darn shame that Java doesn't have those things yet, and I sure hope they add them soon.
When we talk about that, how important do you think languages like Groovy and others, very, very close to Java on the JVM, how much do you think we need to thank them for constructs like for each? I mean, did they really come from?
They did. Honestly, as the person whose baby for each was, keep in mind it was Java 5 that I put that in. That's not what I was thinking of when I put it in. It was just something which needed to be there at the time. But in the intervening years, for example, Java has been in a large part supplanted as the introductory teaching language by the likes of Python. And if I had to guess why, I would say the biggest verbosity still present in Java is, things like collections literals. So I think, that would have given it a fighting chance of surviving as an introductory programming language. I realize that's controversial, but I believe it.
Okay, so we have a question here from the audience. This is from Jane _. Mm-hmm. So, Josh, what constraints do you have from higher management from your for each feature?
And I guess that can be asked just in.
There's a great so okay, the statute of limitations has pretty much expired. Higher management in this case wasn't my immediate manager.
it was Graham Hamilton who basically ran the zoo at the time. And the constraint was you have to do annotations. I basically cut a deal with him whereby if I did annotations, I could also do the features that I really cared about, which were, for each and enums. And yeah, the other ones kind of were they weren't as much my baby, but auto boxing, auto unboxing, they all, the GSR 201 features. But what I desperately cared about was for each and enums. I was told, do the stuff that Java EE depends on, which was annotations. Although the actual, I like the shape, I must say. I like where it ended up. And just yesterday, I was looking at some code that was written on top of it, by someone at a company called H2O.ai or Hexdata, where I'm consulting these days. And it was gorgeous code. I love what people have done with annotations, but it wasn't my baby. I was a hired gun for annotations, whereas I was passionate about enums and for each. So basically, I was not under any specific, management didn't say you can't do strings. That's on me. The fact that I didn't do strings, it was a mistake.
Well, regarding annotations, by the way, do you believe that annotations are abused at the moment?
I think some people abuse them, but you know what? I think some people abuse every feature in the language.
I think, yeah. I mean, one of the things with annotations, though, is you can include so many different libraries and frameworks these days in your applications.
Yes.
Each that I don't think there's any one that abuse annotations much more than the other, although I'm sure Lucas Eder would complain at me for saying that with the EJB
Unfortunately, he left.
spec. Unfortunately, he left. He'll be ranting right now about Java E and the JPA spec and things like that, I'm sure.
Well, they're the people who want them in the first place. Have they abused them? You tell me. I'm not a Java EE person, so I simply don't know. But I look at something like, and by the way, I look at sort of the well-known testing frameworks that use them, and it makes the tests nicer. It's better than name-based patterns that they replaced. And I look at Juice, right? That is the dependency injection framework, Google Juice, and I think it's a fine use of annotations. I have no problems with it. So I certainly think that there are plenty of frameworks that don't abuse them. And I think that the particular take that we came up with, using interfaces in the way that we did, I was accused of abusing interfaces at the time as well, to define annotation types. But I think it really worked out well. I have no apologies for that one.
Okay, awesome. So we have a generics question from Hami6. Welcome to the video again, Hami. In generics, is there a concept of bridge method after type erasure? In JDK 7, when we used javapp command to see the bytecode, there is no bridge method shown. Is this an improvement in javapp command or a change in the concept of the bridge method?
I would be shocked if the bridge methods weren't there. I almost want to run JavaP quickly while we chat, because keep in mind I wasn't there for the release of, although I was heavily involved in Java 7, but I never heard about bridge methods going away. I know the bridge methods are still there. I know they are because I have a puzzler, and it's called glommerpyle. You guys can look it up on the web. GLOMMERPYLE. And I'm slightly giving away the answer to say it depends on bridge methods, but I ran it the other night and it still runs. So bridge methods are still there, and that's in Java 8.
For those who don't know what bridge methods are, how would you describe a bridge method?
Okay. Bridge methods are the VM does not know about generics at all. Basically, the VM was essentially unchanged in Java 5 when generics were added to the language. They're just a compile time trick. But the problem is that when you are doing generics, you create new methods with the correct generic signature, and from the VM perspective, they don't actually necessarily override the methods that they should. So in order to make them do that, the compiler silently emits another method that calls the, that replaces the generic, the type variable with its bound, right? So basically there's an implicit bound, which is object if you just say T, or if you say T extends, number, it'll be replaced by number. But the point is you have this automatically emitted method, which you don't see, that delegates to the method that you've written that supposedly overrides some method. So it kind of produces this illusion of overriding even when the VM doesn't know about generics and doesn't know about the changes in the overriding rules. So it's basically a bridge from the non-generic universe to the generic universe that preserves the illusion that generic types exist at compile time. If that makes any sense. That's a bridge method. And by the way, it is a leaky abstraction. If you look at that Glommer pile puzzle, you'll find out bridge methods were supposed to be invisible. You weren't supposed to ever have to think about them. They were supposed to just do the right thing. And generally they do, but if you ignore how occasionally when you, often when you're using generics, if you're not careful, you'll get unchecked cast warnings, stuff like that. Even when you haven't put a cast in the code, there are automatically generated codes in generic, sort of in the code emitted by the compiler for generics. And if any of these are ever unsafe or unchecked or whatever, that's a real serious problem. Some people ignore them because they just don't have time to deal with them. But ignoring pretty much any compiler warnings can get you in trouble. And ignoring these ones can get you in big, big, big trouble. As I say, Glommer pile, it was in a fairly relatively recent Java Puzzlers talk, like circa 2012. Look it up and you will, once you understand that puzzle, you'll understand bridge methods and you'll understand how they can screw you if you ignore unchecked cast warnings.
Right. So Josh, I also read in your book that one of the reasons you have type erasure was keep compatibility with previous versions.
That was the main reason, by the way. That was absolutely number one reason.
And this comes with a good question from PMM77, which asks you if you're developing a brand new language, will you develop it with type erasure?
No, I don't think type erasure is the biggest flaw in generics. The biggest flaw, as far as I'm concerned, in the whole kind of part and parcel of what came out in Java 5, is closely related to it. And it's auto-boxing and auto-unboxing are the real disasters in terms of, the kind of dough moments that they create when you're debugging code now. And why did we put them in the first place? Really? So that we could have generic types over primitives, so that we could have unity of expression over the primitives. I think Java would have been much better without auto-boxing and auto-unboxing, but with a generic type system that actually did what's called heterogeneous translation on the primitives, that actually emitted copies of the code for the different primitive types, or at least copies of bridge methods for the primitive types. You need copies of the code, actually, now that I think about it. I haven't, it's a non-trivial piece of design. It's actually a fairly serious piece of design. I'm not saying, oh, we missed something obvious. This approach was understood but rejected as too big a change and too much magic. But given how much pain was caused by erasures plus auto-boxing, I would have said no erasures and no auto-boxing. Instead, generics that does hang on. Let's not say no erasures. Yes, erasures on reference types, but no auto-boxing, no auto-unboxing, and heterogeneous translations for the primitive types. That would be perfect. Have I made myself clear?
I think so, yeah. Well, let's see if our audience asks another question related to that. But anyway, also from PM771, what kind of errors you've seen developer uses for generic stuff?
Oh God, so first of all, I see raw types still in this day and age because it's like hard to get the generic stuff to work. And I see a lot of client code that still doesn't actually use generics. Do you guys see that, by the way? Is it just the circles I travel in, or is that common? Okay.
Raw types are the most usual, probably.
Say again?
The raw types. Probably
Yeah, that's what I'm saying. I see raw types, and raw types should have died at least 5 years ago. There should be no raw types anymore. Raw types, I mean, the goal was not to have people continue to use raw types. The only reason they existed was to ease the transition. That the transition should be over. So that's one error that I see in generics. And then wildcards. Wildcards turn out to be extraordinarily difficult to get right. So I see people not using wildcards when they should, so that their libraries are less flexible. And then I see people using raw types to get around the absence of wildcards. I see uses of wildcards that are flat out wrong. So actually getting the producer extends consumer super stuff right turns out to be quite difficult, even for really skilled programmers. This is something I realized when I was at Google, when the likes of Kevin Beryllian, really smart people, they'd use them as best they could, and things still wouldn't work out. And they'd come to me, and I'd say, well, there actually is no perfect solution here, especially when you have sort of more complex signatures where you have multiple type variables with kind of interrelated bounds or recursive bounds. It can get quite ugly. The fact that you have to use recursive bounds to sort of simulate the self type, as exemplified by the nym type in the library, turns out, it seemed like a reasonably good trick at the time, but it still makes people's heads spin, and people often get it wrong. I think generic types are complex. They are so complex that very few honest programmers will tell you they get the generic type signatures right immediately. They do stuff, they throw it at the compiler gives them back error messages, and it's like a negotiation between the programmer and the compiler until they can get rid of those error messages.
Do you feel that the generics are the hardest part of the language to grasp?
I believe so, but keep in mind that is the language up to Java 7. I haven't messed with Java 8, so I don't know if that's still true. Well, I've messed with it a little. That's a lie, but I haven't used Java 8 enough to say I have a deep knowledge of it, and there's nothing as complex as generics in Java 8. But yeah, I think generics are the most complex part, with the proviso that it is not individual features, but the interaction of multiple features that cause complexity. And so sometimes you'll have like auto boxing plus varargs causing hell, or generics plus varargs, because varargs are arrays and generics and arrays don't get along very well, that kind of thing. So sometimes it's combinations of multiple features, one of which is often generics, but sometimes it isn't. As I say, auto boxing and varargs, there are many combinations that can cause complexity and cause pain.
Indeed.
So there's a question from El Sami. So it's quite a generic question, but not about generics.
All right.
So he or she is saying that Java is huge, and there are many things to learn about Java. It's not so easy for a beginner program to memorize everything.
By the way, I'm crying now. See, these are tears.
It's terrible, isn't it?
No, really, seriously. The wonderful thing about Java. Here, I can show you. So, C is an awesome language. I love C, and the wonderful thing about C. Can you still hear me? By the way.
Yeah.
All right. I got my bookshelf over here, and the super wonderful thing about C is that the entire language. By the way, this is my original copy from the 70s. Could be described in a book this thin. I read it on a train ride, and then
book.
Yep. I read it on Trainer. I could program Java afterwards. Afterwards. Java used to be that way. I actually learned Java from this book, including the libraries. This book has, I read it on a plane ride on the way to California for my job interviews. And by the time the plane landed, I thought, yeah, I can program this language. If you could make a book like this these days, it would be that thick. And the reason I'm crying is because at the time when Java 1 came out, it seemed like a total breath of fresh air compared to C++. And Bjarne Stroustrup, who is not so dumb, said something really cool. And wait 2 seconds. I'm going to see if I can pull up the quote.
I have the C++, the complete reference book as well, which is more of the doorstep.
Yep. All right, hang on. Believe it or not, I may pull this off. I'll be amazed if I can pull this off in real time. All right. So, is it in this talk? Ooh, I brought up the wrong talk, dork. All right, I'm going to try one last time. I have the thing quoted in a talk, and I'm trying to just pull the damn thing up. So, and if I can't do it in one more second, I give up. It was this retrospective talk that I gave at, okay, righto. Now I know where it is. Telling you that means I know where it is. So I'm gonna bring it up in. You start the clock now, and if it's not up in 20 seconds, I give up. Okay. Oh, or you know what else? Ask me a question, another question while we're bringing that up. It's your choice. But I'm gonna have.
It's not exactly a question, but I love this comment from Jane because I guess it was related when I asked you about the generics being hard.
Yeah.
Mentioning that head to generic signatures of the new Java 8 functional interface types. I'm guessing.
I'm not surprised. As I say, I am going to say flat out, though I don't know exactly what the perfect solution would have been. Wildcards were a mistake. They were a piece of recent research, and we were convinced that the complexity would be relegated to those who develop libraries, and the users of the libraries could simply ignore them. And that turned out not to be the case. And I'm really, really sorry about that. The complexity that wildcards added to the language was immense, and that's really sad.
Do you feel sorry to add the wildcards to the Java language that time?
Yeah, I do. I mean, I think that I was very much behind it. I'm not blaming this on anyone else, but I think I learned a lesson from it, definitely. I think that putting stuff that's recent research into a language which is, supposed to be not a researchy language, which is supposed to be a working man's language, was a mistake. Yes, I believe that. Unfortunate. All right, almost there. OSCON 2011. Aha! You see, the problem is it was on my server, and that's why I couldn't find it easily.
So you've built it up so much now, Josh. It's got to be superb now.
Well, yeah, it's and so far it isn't even happening because all I see here are the keynotes versions. I know that I generated PowerPoint versions too, but if I don't find them, I'm completely hosed, which would just depress me. My God. I just got them off of a Mac laptop the other day where everything is done in Keynote, hence the confusion. So read the rest of the question. In fact, you only gave me the beginning of the question.
So the rest of the question was, so it's the classic question as to what does a developer need to know? What topic does a developer need to be strong in to be ready for a Java interview? I'll append that question with obviously, there are plenty of general Java books out there, and in fact, you showed one which is Java in a nutshell, and this is all about kind of understanding structure, understanding syntax, and so forth.
Yes.
But essential Java is a lot more about advice about how to become a good developer. What would you say the key parts of there are in Java to learn in order to become a good developer?
All right, so there's a lot of parts to that question, but so in fact, read me the part of the question before, what's it take to become a good developer? I can answer that one, I think.
The question was, where do you need to start to be able to get the best grasp of Java? What does a developer need to know, or topic a newbie have to be strong in to be ready for a Java interview?
To be ready for a Java interview. All right, yeah, so Java interviews can be...
You work for Google at some point, so you must know about these ridiculously long Java interviews that went through.
Yeah, I've heard about them. I feel bad. I tried to give good, fair interviews when I was there. But anyway, so to be ready for a Java interview, I think, when I think about it, honestly, a lot of the people who did well, and you're going to hate this answer because I saw the other day, a thread with thousands of, just it attracted a lot of attention, dissing the whole interview process at Google. And one of the things that I saw that they didn't like was, in essence, computer sciencey questions. But I think the people who are good at Java are good at the fundamentals. People who do poorly in Java do poorly because, I'll ask some question which is fundamentally about the integers. I don't know what. Let's say, just write me a decent piece of code. It doesn't have to be rocket science, to tell me how many 1 bits are set in an integer. I think that's a fair question. And people will print it out in binary as a string and start doing string processing. Well, you could screw that up in any language. That's not a Java issue if you screw that question up. It means, you don't have a good grasp in sort of how the whole stack looks. If you understand the way computers look and the way they process stuff, kind of an instruction at a time, and what the fundamental data types are, that integers are in fact 2's complement 32-bit things, and you can mess with the individual bits of them if you want. So, first part is, I think you should just have a good grounding in the fundamentals of, I could call it computer science, computer engineering, or whatever, but sort of the same things that would make you a good C programmer will also make you a good Java programmer, but Java adds some stuff to the mix. So sure, you should understand the type systems. You should understand clearly the difference between reference types and primitive types. You should understand something about inheritance, something about the difference between overload resolution and dynamic dispatch. You should understand something about the performance consequences of what you do. I don't believe in premature optimization, but on the other hand, you should understand that doing stuff with regular expressions is way, way, way more expensive than, shifting and manipulating integers. So that's kind of part of that.
Yeah, I guess the following question is easier to ask now. Are those the same aspects which would make someone a good developer?
Yeah, absolutely. I know people want me to say no. I know that right now, interviews, and in particular whiteboard interviews, are getting dissed all over the web. But I believe, and I'm sure there are people who give awful interviews. I don't think interviews should involve primarily trivia. One thing I forgot to add is libraries. A good grasp of the libraries is a wonderful thing. If I ask you an interview question where there's a canned solution in the libraries, and you either know about it, or you even say, I think it's in the libraries, Josh. Can I look on my, can I just look it up in Google here and find out if there's a library function to do that? I'll say, hell yes, go ahead. I think interviews should be as realistic as possible. It's not about having memorized everything, but I think having at least a good grasp of what's there in the libraries is really important. And I think it's important both for passing interviews and for being a good programmer.
Yeah, and I think I know a couple of amazing developers. Marcus Lagergren, Oracle. I'm sure you know Marcus.
Yep, I do.
And also Tim Fox from Red Hat, the guy who's leading the Vertex project. Two amazing, astounding developers, both projected from Google. As in there, I don't think Tim even got to the interview stage. I was reading it on Twitter from their discussion. It's like, so it's not just people who are still very new to Java that could potentially fall over an interview. It's equally about your style, I guess, to the content you know.
Yeah, and Google is not alone. There are tons of good programmers who have been rejected at tons of companies, just because of what they were looking for at the time when they interview, or whatever, or screwed up interviews. Who knows? But I think that Google's the whipping boy right now because Google is so big and has such a large fraction of the very good programmers. That if people want to beat up on programming interviews, they beat up on Google. But I don't think you'll find that other companies are immune to this sort of thing, to be fair.
Well, I feel that in the end you're looking for someone that can actually understand the problem and solve it, not just like memorize wherever APIs there is there and just like type them out very quickly.
Yeah,
that's not what you're
totally. No. Honestly, I think that speed is massively overrated in this whole game. And by the way, I'm not saying these things are bad, but the programming contests that they have, which are all about speed, knowing kind of upfront what libraries exist and how to get that solution out as quickly as possible, do not emphasize what it takes to make you a good programmer. Good programmers, good programming is about making something that is readable, modifiable, usable over the long haul, well factored, well thought out, and that takes time. It's not about how rapidly can you bang out something that barely works.
Which is why it's so hard to get good developers just through an interview, right? Because there's a lot more to it than just knowledge. Let's get back into some tech questions, Roberto.
Yeah, sure. So,
but I reserve the right, if I can dig up this damn quote, to read it. Okay.
Absolutely.
Sure. So let's change a little bit here our discussion. So this is from Jane, and the question is, why do you think that list and maps and literals are still missing from Java?
Because I'm not there anymore.
Okay, so you have to return then.
No, that will never happen.
So that was something that you were keen to do.
Oh, totally. Yep. I mean, I wanted to get it into Project Coin, but I didn't have a good enough proposal ready for them. And the other thing is that there was only a certain amount of stuff they were willing to add. But honestly, I think that was the obvious next feature to add to the language. After Java 7, well, really, after Java 7 was out the door, that's the next thing I would have done. I think that one feature would have been more useful than most of what was added in Java 8. And I understand that's controversial point. But it's the way I feel.
I'm going to think out loud here. Is there a second part to Project Coin? Wasn't there a Project Coin Part 2? That was.
It's going on right now. You can look on the web. I think it's called like Milling a Coin or something like that. And by the way, the guy who does that stuff, I have immense respect for him, Joe Darcy. He does a marvelous job. I think it's really, really cool that no puzzlers that I know of have come out of coin features. I think those were among the most carefully designed features in the language. So 2 thumbs up to Joe Darcy and the whole Project Coin team. But part 2, the milling part, is really, really small. It's all about kind of taking any rough edges off of Project Coin features instead of doing another Project Coin, doing a bunch of other language changes of that level of complexity. Basically, I think what Java needs now in the way of language changes are things that do not add to the conceptual surface area, but make it easier to express the things that you already do.
Mm-hmm. Okay, so we have another question about builders from Steve C. Tian.
Mm-hmm.
When using builder, should we consider static factory methods like builder instead of constructors like capital B builder?
Let me see. You know, I don't think there's any disadvantage to it. You know, I believe that typically builders are fairly simple objects, and the reasons that you normally prefer static factories, sort of flexibility to allow you to return different implementations, or, you know, certainly you're not going to reuse builders simply because builders are inherently stateful. Builders are a way to collect state before you create an object. So, you know, I don't think you need to preserve the freedom to give two people the same builder, because you're never going to do that. So I think that it's there's no huge compelling reason to do it, but no compelling reason not to do it either. How about that? I wouldn't see it as wrong, but I wouldn't necessarily bother either.
Okay, awesome. Yeah. I've got a couple of questions from Java Guy. Do you want to start with?
Yeah, sure. So Java Guy says, he hears a lot about serialization being bad. And the book that you wrote also supports that's a little bit bad. Instead of using a platform that's a neutral serialization mechanism like protobuf or any other stuff, isn't Java serialization better to use for exchanging data between two Java systems?
I don't think so. You know, I mean, you can read the whole chapter on Java serialization and come to which is not in today's. I don't think it's like the last thing in the book. But I think there are enough gotchas in serialization, and it's expensive enough that you know, I think the places where it is the best solution are actually quite small, and you know, things like JSON or whatever I think are great for what they're used for. So you know, although he did say between Java systems, you know, there are times when it's easy to use, and you can take fairly complicated Java objects and just sort of hurl them across the fence. But you know, the moment you add persistence into the mix, or heterogeneity where you have multiple versions running at the same time, and there are, you know, you've got to make sure that the serial forms are consistent from version to version, it just gets very ugly very quickly. So you know, I'm not going to come defend serialization. I didn't totally trash it in the book. You know, I kind of said it's there. It has downsides. Here's how to use it to best effect. Here's what to be scared of. And if you, I think the title of that essay was, you know, something like use serialization judiciously. It's like, if it's the right thing to use, go ahead and use it. But if there's an easier solution, use the easier solution. Serialization it's specious. It looks great. It's a siren. It's tempting. Just say implement serializable, and all of a sudden, gosh, you can pass it, you know, across the wire, and you can store it and stuff. It's not that easy, you know. Basically, there are dragons lurking in those waters.
Mm-hmm. Awesome. And a second question from Java Guy.
Okay.
I'll give a bit of background on this from a previous VJug session that we had. Actually, I think it was a Kotlin session, and Hadi Hariri was talking about how people in, you know, Java developers, they tend to use objects because it's easier rather than you know, just because they actually want something to be encapsulated in an object. And a great example of this is a tuple. So you know, people want to return more than one thing from a method, and the typical way people would often do that or get around that is by using creating an object, because Java doesn't have tuples. So the question is, your thoughts on tuples then, for you know, adding tuples to the Java core library? Do you think that's a good thing or a bad thing?
Tuples are, you know, I don't think tuple types are necessarily a good thing, because of the fact that, you know, people use them not just to return a couple values, where there are two distinct values to be returned, but to pass around two things, let's say an XY point or whatever, and often there is semantics beyond the fact that it's a mere tuple. And if you simply use tuple types, you lose so much. So pair, in fact, the pair type was probably added to Java 8. You tell me. Was it added? I think it was. I know Guava had a pair type, and I think it's not necessarily a good thing. It makes code harder to read, and it removes an opportunity to do, to basically have some sort of invariance for your type. Java is primarily a language based on nominal types, not a language based on structural types. And tuples are structural types, so I don't think they necessarily belong in the Java type system. Would it be nice to be able to return a couple things? Hell yeah. So if you look at, let's say, binary search, which I added in whatever 1998 or something like that, it's really annoying because what it's returning is basically one position in the array where the thing either is or would go, and then a Boolean saying either I found it or I didn't, and I have to take these two things and combine them in a fairly hideous way. I complement every single bit in the result if it wasn't found, thus guaranteeing you a negative number if it wasn't found and a non-negative number if it was. But that's really ugly, right? It's a kind of me struggling with the fact that Java doesn't have tuple return types. If it were easy to add tuples as return types, I think it should have been done and would have been done. Smart minds, including Guy Steele, tried to do it, and it turned out to be much more difficult than you would expect. So I think having a way to return more than one value from Java would have been nice, but I think people kind of tried and gave up.
And your preferred workaround for that is what, like a data object with a couple of...
Depends on what the two things I'm returning are and the performance demands. So for binary search, which is something that runs in log n time, I think I did exactly the right thing by simply combining a Boolean and an integer, or a Boolean and a non-negative integer into a signed integer in a sort of a horrific way. And I understand that that borders on abuse, but I still think it was the right solution. Often you're sort of forced to create a data type. Sometimes you use arrays. I've seen things that want to return several integers, and instead they return an integer array. So that's basically using a nice small object. They're taking advantage of one that already exists. And I feel your pain. I think that there's no great solution to this one. Either make yourself a little object to contain your return values. Once in a blue moon, you do that and you realize, oh, actually it's a nice little object type to have. This thing is naturally returning an object. So occasionally it works, and often it's just kind of unpleasant. And you make an object that has no use other than returning these multiple values.
Okay. We do have a question here from Hermit Things. It's not actually related with the book, but I'm guessing that people know that you're very knowledgeable about Java, so they're asking these type of questions.
Fine.
Okay. So Harmon Singh wants to know what's the actual concept behind the InvokeDynamic in Java.
You know what? So basically, that isn't even a Java question. That's a Java VM question.
Yeah.
And it is not exactly my area of expertise. I'm going to answer it only in the vaguest terms. It makes the the calling convention that's implicit in the Java virtual machine was designed for the Java programming language, and it turned out to be inappropriate for highly dynamic languages. In particular, languages like Groovy and Clojure and stuff. It just you get more. You want an additional layer of indirection in the calling to do these highly dynamic languages, and it turns out that by adding this very flexible calling convention to the virtual machine, they could get much more efficient implementations and natural implementations of these other languages that aren't Java. And yeah, it was also used in Lambda, the Lambda implementation, but it didn't have to be. It was just an implementation detail. So I think that's all I'm going to say about it.
Mm-hmm. Okay, so we have another question. So nowadays we have plenty of programming languages available on the JVM if you wanted to choose something on the JVM. Scala, Clojure, plenty of others, Groovy. What are the kinds of things that need to be considered before choosing a programming language to actually learn? It's another general question here.
Yeah, and it depends what you're learning it for. Obviously, a language is a culture more than it is anything else. A language isn't just a set of syntactic and semantic choices. It's who uses the language, what they've done, who you'll be working with once you learn this language, what sort of software you'll be building with this language. And so that determines which language you'll learn. If I were learning my first JVM language, it would almost certainly be Java, simply because it's the lingua franca. You can read everybody's code. You can, there are tons of jobs that will be available to you because, everybody uses Java. If I were particularly interested in functional programming and the way functional programming interacts with object-oriented programming, then I'd learn Scala, because it is a very clever person's take on how to combine functional and object-oriented programming. It's also, it's got a complicated type system, so I would be prepared to learn that complicated type system. If I loved functional programming, maybe I've had some previous experience in Scheme, and I wanted to be able to do that on the VM, of course I would learn Clojure. And by the way, notice I'm picking the popular ones. There are advantages to picking the popular ones. You have a lot of other people who have used them as well. You have a lot of code in there. If you run into trouble and you ask a question on Stack Overflow, someone will answer it. If I were sort of particularly interested in, I don't know. I think that's the basic idea behind how I would choose a JVM programming language, and those are sort of the first three that I would go to. But on the other hand, I should also say I haven't learned all of them by a long shot. I only have the vaguest exposure to Kotlin. It seems like a nice language. The only problem with it is that not a lot of people use it. So if you learn it, you're probably learning it more as a language scholar than as I'm using it for my job programmer.
Yeah, and I guess also I've played with Kotlin a fair amount, and I quite enjoy it. It's a nice language to develop. But I guess the things when you the language which is still very young, it also depends if you're learning it for a reason, like because you wanted to build an app for a company in it. And I guess the other thing is you got to be careful about the age of that language, because you still want it to be there and be supported in 5 years' time if you put something onto production.
Yep, absolutely. Basically, you're making a bet when you write in a language, and sometimes you end up using being stuck in time. If you pick something that is kind of a terminal, you can still use it, but you won't get any updates. And your system can get awfully crusty. So I guess that's my answer. I would also say that as a young programmer, the more languages you learn of the more different types, the better. You should know an object-oriented language. You should know a functional programming language. You should know an assembly language. You should, or at least you should know C, and you should know how to use C to mess with the machine. You should try to write a device driver. It's not that hard. And if you've done that, you'll be a much better higher level programmer because you know what's going on underneath you.
This is a great point from Martin Thompson as well. I'm sure you know Martin. He talks. He's worked in London for many years for finance companies. He calls this thing called mechanical sympathy, and it's about saying you don't have to be a mechanic to drive a Formula One car, but you have to have a good understanding about the machinery that you're using in order to get the most out of it. And it's very, very similar with development, particularly when you are developing in a concurrent, multi-core environment. You have to understand, your how a single core acts, how two cores act, what the actual implications are of concurrency and things like that. It's a very similar point, I guess. So we've got about 5 minutes or so left. Probably about enough time to take a couple of more questions. We've got 2 great ones about the book here. So Roberto,
so finally, I think a couple of questions about enums. So using ordinals for enums is usually a bad thing. You actually recommend not using it on your book. But Xavier here is asking if there is any case where it's okay to use an ordinal, for instance, when translating from a database column to enum or something else.
I do not think it's good for database column to enum. Okay, I think there absolutely are cases where you should use ordinal, and that's why I put it in there. You use it when you're writing data structures, that need something that is guaranteed to be unique for each enum value and guaranteed not to change for the duration of the lifetime of this VM. If that is sufficient for your uses, go ahead and use it. But database columns, that sounds to me like something persistent. For me, if I were going to do that, I would associate a separate value with each enum type constant. It might start out being the same as the ordinal. And you know what? After a few releases, it might not stay that way, because you might want to keep these numbers, but put something in between them in the enumeration, because something belongs there. But because those numbers are already on disk representing those particular enum values, you don't want to change them. Hello, well, this is my son, Matt, who's crossing through, so you'll see him. Matt, wave at the camera. Anyway, so yeah, basically to me, that is exactly what I don't want people to do with enums. Don't use enums to represent your database columns. Associate a value with enums. And if you look at any of the sort of simple enum examples that are around, like enums for planets, or enums for playing cards, or what did I do? Enums for yeah, it doesn't matter what. You'll see that a very common pattern is just passing an int into the enum when you create it, and using that enum as a part, that int as a part of the enum's internal representation. Do that instead.
Okay, awesome. So we got one final question, also a little bit about enums. Any regrets with regards to how enums support per enum value initializer blocks, causing the initial enum values to be an instance of an anonymous subclass of the enum type? I think I said enum enough there.
Yeah, I have to think about this a little bit, because an anonymous, yeah, absolutely. That is basically, if you have some code particular to an instance of an enum, then you get an anonymous subclass of your enum type. Do I have any regrets? Yeah, so I wish that the asker were live online, because actually I don't. I think that works out just fine. I have no problem with it. But if he has a problem with it, I'd love to know what it is. Okay,
so let's ask that, and I think if you want to ask that in IRC, if Maldiva thinks, in fact, Maldiva, that's one of my friends from Zero Turnaround. Let me
actually check. We could bring him on board.
Let's see if he's around.
All right, do that, because as I say, I'd love to know what the problem is.
He's a very smart guy. Actually, he's a Danish guy who I believe lives in Tartu in Estonia. Let me see if he'll join.
So, I wouldn't be surprised if there were an issue, but I haven't run into it.
And for those of you wondering, when Josh was thinking, then that's actually Josh's mind compiling the question.
So basically, one good thing that you get out of that approach is you get very fast dispatch, right? You get dispatch to this different implementation of the method for each enum constant just about instantaneously, because you're using the language's dynamic dispatch facility to do it. So that's a good thing. But I know that's performance. Performance is not the main reason you do something.
Okay.
I guess one downside is it gives you confusing, if you're looking something down at the VM level, if you're looking at the bytecodes, you might be confused by them, or even, perhaps if you're doing kind of debugging and you print the class object or whatever, you might be confused.
Okay, so I don't think
he can't join us.
I'm not sure what he's wearing or where he is, but he can't join us right now. So we could maybe push this question.
Send it to me, and I'll answer it via email.
Awesome. So that's actually us at the top of the hour now, just passed. So again, another massive thank you to Josh Bloch for joining us for this session. It really is amazing to hear from you. Some of the reasons decisions were made in Java, and it's wonderful when we talk about things like for each and stuff like that, how it's like your baby and stuff like that. It's
awesome to have someone here that actually worked on the features themselves and actually can tells us why they choose this path or they will go another path. So actually telling us how you went with the for each and that you have to do generics first. And
well, thank you.
And and
it's very, very awesome.
So what we'll do is we'll pass that across to the next session or
so basically we're planning like a first session. So Josh, since you're being for the first two, do you want to be on the final session to cover the rest of the book?
Wonderful.
Awesome. Thank you so much.
What I'll do is I'll send you an invite this time.
Here's my promise. If you let me, I'll open the next session. Quote that I couldn't come up with on the.
Perfect. That sounds awesome.
All right.
Let's do that. We'll open with that session, and then we'll have that question from Maldiva.
Yeah. So for the next session, it's going to be on 7 July at the same time, so 5 Western time.
Is that going to be good with you, Josh, for Independence Day celebrations and stuff?
Okay.
It is perfect.
So feel free to join everyone that's on IRC and tell your friends as well.
Absolutely.
You'll enjoy
We've had some great comments on IRC and great comments on Twitter as well for what a great session and discussion it was. So thank you very much for everyone.
Yeah.
Thank you for everyone for contributing questions. That's been really driven the session. And I'm sure we could carry on for about 5 hours with all the questions that we have that we can continue to ask. So yeah, let's talk about that in the next session. Just a little bit for VJUG members for the remainder of this week. Because we're at Devox the next few days, we have 2 sessions, one on Thursday and one on Friday. Let me just grab them up. On the Thursday, we actually have a live session with Mr. David Blevins from Tommy Tribe from your neck of the woods, right?
Yeah.
So for those of you who don't know, Roberto has joined Tommy Tribe.
Yeah.
I think we may have mentioned that in the last session,
on the first session, yeah.
So
we actually also sponsorship in some way the VJUG by me standing
That's
here.
right, of course. Why not? And so we have a session from Apache Tommy from Dev to Ops. So this is going to be a nice hacky style session, and that's going to be given from the auditorium of Devox UK. So feel free, if you're at Devox UK, to come by. If you're local to London, it's actually a free session to come to. It's a community part of the of Devox UK. So come to that and be part of that, and we will be showing that live on the virtual jug as well. So we'll take questions from the room as well as online. On the Friday, for those of you who don't know what one of these hacker gardens are, it's a live kind of style hackathon, which tends to go throughout the day, but is themed at different parts of the day. And we try and just make Java better. So the area which we're going to be covering is the OpenJDK. And we're going to be doing things from fixing small bugs across to translating different docs, and it's really to show you the process of how you can get involved. And we don't just want to literally show you how we're making changes to code, how we're grabbing bugs and pushing patches. We want you to actually join in remotely, do it yourself, and we can help support you. So definitely join that one for a bit of fun with the OpenJDK, and we can hack along live. We also have another session next week, but I'll talk about that over the next couple of VJUG sessions. So once again, a massive thank you to Josh.
Thank you very much.
Over in California, right, Josh?
Yes, I am.
Beautiful, sunny California. So enjoy your day, Josh. It's just starting. And
enjoy your evening.
Say again?
Enjoy your evening.
Thank you very much. Yeah, and
we're just finishing our beer.
We'll say cheers. And see you at the next virtual jug. So thank you everyone for attending, and see you again soon.
All right.
Yeah.
Cheers.
Thank you so much, guys.
Goodbye.
Bye-bye.